Hey everyone, what's going on? Welcome to Focus AI. So here in this video, we will check like what are the training and testing process or phases of KNN. Okay. So before going into the details of the train test phases of KNN, let me show you what are the prerequisites of this. So the thing is that we have a data set. So the data set is I'm calling as D all, which consists of n data points. Now what I'm trying to do here, I am splitting the data into dtrain and dtest. Dtrain consists in 1 points and dtest contains in 2 points. So the thing is that I will come to the point that why we need splitting. I will come to that in a short while. So what I'm doing is that I'm having the overall data, I'm converting or I'm splitting it into dtrain and dtest. So now for splitting, we have to have three conditions to satisfy. The first condition is that n1 plus n2 should be always equals to n. So n1 is the training data points, n2 is the testing data points, and n is uh, the overall data points, right? The union between dtrain and dtest should be d all, and that's very evident, right? Because we're actually splitting dtrain and dtest from d all itself. Okay. And the third point is that the intersection between dtrain and dtest should be null. So what does that mean? There should not be a single data point present in both dtrain and dtest. So these are the three mandatory conditions for splitting a data point into train and test. Okay, so first let me cover why we need splitting. Okay, now I have written the definition like to perform proper evaluation of the model with unseen data, which is the d-test, after training with the training data d-train. Now let me tell you the main important objective of machine learning. That is, you are building a machine learning model. That is fine, but you have to deploy it, right? You have to deploy and productionize your model. Now you trained the model, you got good accuracy, you are satisfied with your model and you deployed it, but unfortunately, due to some reason, it's not working good for the unseen data or the future data. After productionization of the model, future data will be coming, right? And the model has to perform well on that unseen or future data, right? But somehow it's not happening. Then there is no meaning of deploying it, right? And then there is no meaning of that model itself. Then how should we ensure that our model is now enabled for deploying? Now the very first step is that splitting your data set into dtrain and dtest. Why? Because we after splitting we will separate this dtest, we will isolate this dtest. We won't allow our model to touch this dtest. Whatever we will do using dtrain. Okay, whatever we will do, the training of the model and then whatever the training steps and training phases were there, we will do using dtrain. Once we are satisfied or once the model has been trained, we will use dtest to actually perform the proper evaluation the model, because the model haven't seen this dtest at any point of time, right? So it will be best for the model evaluation. Okay, now I will make videos, future videos on how are the how we can do these things, how to come up with a proper approach. I mean maybe the next video is on that only. So but the main reason behind splitting the data is that to perform our main objective of machine learning, that is the model should perform well on the test data or the unseen data. Okay, so that is called the model generalization. Okay, now you might ask like what are the splitting strategies? Now to be honest, there are many splitting strategies. Okay, so I mean you can invent your own, you can discover your own splitting strategy. Once you have the experience, you have the domain knowledge, based on the data also you can split your own data. But typically in general and widely used splitting strategies, random splitting. And what do I mean by random splitting? That is, you have these data points d all. Okay, now you will shuffle it randomly. Okay, once it has been shuffled randomly, Then take 80% data as D-train and 20% data as D-test. And it's done. Splitting is done. Now, this 80-20 ratio or 70-30 ratio are the most common and general ratio, but it's typically in this range. I mean, I have seen people, even I have also done like 50-50 ratios, but it depends. Again, it depends. But typically, it's the majority would be in the training. The minority of the data set should go into the testing data set. Okay. So this is the matrix notation. If you see the iris data sample, so this is if this whole matrix is our d train d all, then we have to split our data. Say up to this many portion, it is d train, okay, and the rest is d test. So we'll isolate this d test. We'll do the training, and whatever the training phases and steps are there, we'll do performing d-train. Once we are satisfied, we will try to evaluate the model using d-test. Okay, so this is the thing. Okay, so let's go to the next. The next objective, that is, what are the training, testing, and evaluation phases under KNN. So if you forgot what is KNN or how does KNN works, so let me just tell you in brief, like how does KNN performs. So you have the training data, which is denoted as DI here. Okay, now this is a two class data. It is having positive class, it is having negative class. Once it is there, you are given a query point. This query point, the KNN model will evaluate the distance of all the training points with this query point. It will find the distance between these 2 points, it will find the distance between these 2 points, it will find the distance between these 2 points, it will find the distance between these 2 points. It will try to find the distance between each and every points under D train. Once all the distance it has accumulated, then it will find the nearest distance to actually detect the nearest neighbors. Once it got the nearest neighbors, it will encircle like that. It won't encircle, but just for your understanding simplicity, I am just saying that it will encircle that, and it will do the majority vote, that out of these k nearest neighbors, what class, the majority of the neighbors fall into which class, and that will be the target class or the predicted class of this query point. So in training step, what is happening actually? Nothing. It is actually saving dtrain. In training step, it is nothing is happening. It's actually saving dtrain. Dtrain means both the feature vectors and the labels in the memory. Memory means I am saying RAM. Okay. Then while the training process is done, it is calculating the training accuracy. That means it's 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 actually validating the KNN model by the training data itself. Okay. But specifically what is happening, it is actually saving or loading the D train, that is the feature vectors and labels, into the memory. Okay. Once this training step is done, there comes the main important step, that is the testing step. So in testing step, what is done? It is iterating through each and every point under D test and calculating distances from all the points under D train. Okay. Once all the distance for all the points under D test has been calculated, then it will return the k nearest neighbors for each test points. Okay. And in the last step, what it will do, it will conduct the majority vote and predict the class level. Three simple steps. You have the query point or the test point, calculate all the distances from dtrain points. Then in the second step, return the k nearest neighbor points based on the smallest distance, and in last, conduct the majority vote to predict the class level. Okay. Once it is done, we are coming to the evaluation phase. So in evaluation phase, what we are doing, say we are actually calculating accuracy. Like for D test, while we are splitting, we splitted both the features and the true labels, right? So for D test also, we have the true labels or the actual labels. And in this third step, we are getting the predicted labels. Then we will compare that how much prediction the model got it right. That is the main evaluation of our model. So say out of 10 test data, the model predicted 8 correctly. So What is the accuracy? Accuracy is 8 by 10, that is 80%. And what is the error? 2 by 10, because 2 is the incorrect predictions. So 20%. Okay. So this is how accuracy and error is calculated in KNN. Okay, that's fine. So now once these training and testing steps are done, so basically like you are working in a production grade project. Okay, now you have to do classification. So there are many classification models available. Now you have chosen KNN. There should be some strong point you should choose KNN, right? So that is the main point I will be covering right now, that why choose you KNN and why not. So this is the this is the most important thing, the space-time complexity of KNN. Just to understand whether this model KNN model is viable for your production grade project or not. Because if we if we continue to analyze the space complexity, as I have said, that when you will deploy your KNN model, you are actually deploying or storing all the training features and labels inside your RAM or inside your memory. Say you are working on a data set having 1 million data points. So you are actually storing 1 million feature vectors with D dimension each and 1 million true levels in the memory. So now it's huge. You need a good box. It's not a good box. You need a huge box. Okay, having say 64 GB of RAM, because it will be stored in the RAM itself. Otherwise, the operation won't be. The distance calculation won't be faster, right? So what is the space complexity or the space required? It will be in the order of ND, where N is the number of data points under D train, and D is the dimension of the feature vectors. Now, if D is much smaller than N, the number of data points, then obviously it will be approximated to O of N, order of N, but typically it is order of ND. Now, coming to the time complexity of inference time complexity, or what is the inference time or the prediction time? The model has been deployed. Okay, fine. You had a huge box, you deployed your KNN model. Now I am giving, or the user is giving a query point, and it is expecting that my output should become within a second, not within a second, within few milliseconds maybe. But is it happening really for KNN model? That you have to analyze. I would say no, because whenever we are giving, or the user is giving a query point, based on that query point, actually what is happening, all the distance from the majority vote, all the distance from the KNN is calculated, right? And once, for each and every point, the D train points distance are calculated. The distance between all the points between the query point and all the D train points are calculated. Okay. So again, if you see, the time required is O of ND. So N is the number of data points present in D train, and D is the number of, D is the number of dimension of the feature vector. So this space and time complexity is alarming. So before you productionize, or before you try to build a model, a KNN model for production, try to be very cautious that you are ready. Okay. Otherwise, it would be a mess. So this is the end of the video. So what we have learned uh, how to split the data into D-train and D-test. What are the phases, training, test, and evaluation phases of KNN, and what are the space and time complexities. So in the next video, we'll try to cover something more on KNN. And yeah, this is the end of the video. Have a nice day. Thanks for watching.